Geostrophic wind is modeled considering the situation when only pressure gradient force and Coriolis force are present. Pressure gradient force is created due to pressure difference between two places, areas. Closer the spacing between two isobars. Higher the pressure difference and higher the PGF and stronger will be the wind speed. Winds start blowing from high to low pressure area but within 24 hours. Under the influence of Coriolis force start curving to the right in northern hemisphere and to the left in southern hemisphere and finally gets parallel to isobars. PFG and CF balances out each other. Wind direction is straight and parallel along the parallel isobars. Geostrophic wind speed will be higher near equator as compared to near poles for the same pressure difference since Coriolis force is weak near equator. By now you would be knowing that Coriolis force is 0 at equator and max at poles. For geostrophic winds, as you go to higher altitude at the same location, wind speed would increase. This is due to the fact that atmospheric density reduces as you go higher, so less resistance to motion and hence higher speed of winds. 2. Wind is considered to be geostrophic above friction layer starting from 2,000–3,000 feet and goes all the way up to tropopause. Since below friction layer, due to local condition, terrain and obstructions, the mathematical modeling will not work out and would give incorrect results. Further, wind is considered to be geostrophic above 15 deg north, below 15 deg south latitude, since below 15 deg latitude CF is considered to be negligible. So surface winds as well as winds within plus 15 deg latitude is not considered to be geostrophic. 3. Geostrophic wind will always blow along straight and parallel isobars under the balanced forces of PGF and CF. Wind direction can be found using By-Balot's law, which states that if an observer is standing in northern hemisphere with his back towards the wind, low pressure area would be on his left. And reciprocal would be the result in southern hemisphere. Questions invariably comes during exam on interpretation of By-Balot's law. Sometimes question is twisted in terms of port, starboard drift of aeroplane, which can be worked out using wind direction. So in northern hemisphere if aeroplane is experiencing starboard drift, he is flying towards low pressure area, and if experiencing port drift, he is flying from low to high pressure area. We can add one more twist here on altimeter readings. In northern hemisphere if aeroplane is experiencing starboard drift, he is flying towards low pressure area and altimeter will overread using high-low-high principle. So lot of variables can be injected for questions on By-Balot's law. 4. For a given value of CF wind speed will increase if latitude is less, near equator, and density is less, high altitude, gradient wind. 5. Gradient wind is the mathematical modeling of winds blowing in, around curved isobars like in cyclone or anticyclone. And when there is curved, circular motion involved, centrifugal force comes into play. Centrifugal force is experienced by all objects moving in a circular path which tends to push the object radially outwards from center of the circle. So gradient wind blows under the influence of three forces, PGF, CF and centrifugal force. Wind blows parallel to isobars but follows a curved path. In gradient wind there are three forces. PGF and CF would always oppose each other, but centrifugal force would assist the CF in cyclone, low, depression and oppose the CF in an anticyclone, high. So this additional centrifugal force will tend to slow down the speed of winds in cyclone, low, depression and accelerate the wind speed in anticyclone, high for the same given PGF. 6. Question can be based on this effect of centrifugal force on wind speed. Gradient wind in a cyclone, low, depression would be weaker than geostrophic wind. Gradient wind in an anticyclone, high would be stronger than geostrophic wind. This does not mean that both type of winds is blowing at the same time. It is just that which wind modeling will give what kind of prediction for wind speed. 7. Anti-triptych wind or cyclostrophic wind, geostrophic or gradient wind. For both of them to be modeled, presence of CF is mandatory. So what about the winds in geographical areas within plus 15 deg latitude where Coriolis force is close to 0? Winds within plus 15 deg latitude where Coriolis force is negligible is called anti-triptych wind or cyclostrophic wind.